Hi, in this video I'm going to talk about compiling C++ code in Ubuntu environment using the CMake tool. This is the example that we are going to use to compile and use the CMake throughout the presentation. Suppose we have a folder called example_1 and this folder has three files: the main.cpp, person.h and person.cpp. The person.h file contains the header of the class person. This class person has a constructor and it takes name and age in its parameter, and it has another public method called print_person_info that's supposed to print information about the person, name and age. So this is the header file, and this is the source file person.cpp, which contains the implementation of the class person methods, the constructor and print_person_info. And here we have the main.cpp, which uses this class person, so it creates object of type person, and it's just calls its public method print_person_info. Here is the traditional way to compile using G++, and we mention all the source file, and this is the output, main, the executable. And this is the traditional method. It's easy to use when the project is not complicated. For large projects we need an alternative way. This is why we are going to use the CMake tool. In order to do that, in order to use the CMake, first of all we have to add a new file to our project. This file name must be CMake lists.txt, as you can see here, and inside CMake list.txt we define new methods and variable, or we call some functions. The first one is project, and this is like setting the project name, and I did the same name, the folder name. You can put any name for the project. The second method is set. Set is defining a variable called sources, and this variable contains a list of source files, main.cpp and person.cpp. Add executable. By this we say that or we are telling CMake that we need to compile or to generate an executable file called main using the source file defined in the source variable in the previous from the previous line. And so now our file is ready, and as you can see here we have the source files in addition to the CMake list.txt. Now to use the CMake, first of all we have to call CMake command, and we give it the path to the directory or the folder that contains the CMake list.txt. In this case it's dot represent the current directory where we are now, and calling CMake dot, it generates many intermediate file. First one is CMake cache, CMake files, this is directory, and CMake install. We have the most important one is the make file, and because it successfully generated the make file, it means that we can now call the make command. the make command will generate our executable, as you can see here, executable main. So after calling the make command, now we can see the executable main, which is the same name we defined in the add executable method, and now we can call this executable safely. Now, because we called the CMake dot in the previous slide, all the CMake generated file are generated inside the project directory beside the source code files main.cpp and person.cpp, and this will make our project dirty and not organized. So the solution is to create a separate folder for the CMake output file. Let's call this folder build. So here we create, first of all, let's remove the previously generated file from the CMake, and our directory now is clean. We added and created the folder build, as you see here, and now we go to this folder build, and we call the CMake command the same way we did previously, but now CMake command, the path to the CMake list file is in the parent directory, not inside the build. This is why we provide it with 2 dots. 2 dots means the parent directory, which is the correct path. And now all the CMake intermediate files generated inside the build folder, not the parent folder. And also we can call the make command because the make file also generated successfully, and the make will generate our binary or the executable main. And see here how the parent directory that contains the source code remains clean. All the generated CMake files are inside the build. Now you can do whatever inside it. Even you can remove this folder and regenerate or recall the CMake safely. Let's add more files to our project. We added 2 files, student.h, student.cpp. The student.h contains a new class called student that inherit from the previous class person, and it overrides its method print person info. And student.cpp contains the implementation for the method in the header file, and the main function is now create object of type student, and it calls its public method print personal info. So because we added new files, we have to update our source list in the CMake file, and we added the student.cpp in the source variable, and we use the same commands, cmake.dot and make install. And instead of doing this, list all the file explicitly, there is another way to do it, using the file GLOP, and by this way we are telling assign all the CBP file to the variable source, so no need to mention explicitly every file. This is easy to use, and it's preferable when the project is simple. But from the CMake documentation, they recommend to use this method to mention every source file explicitly instead of using file GLOP, because it has some problem. When the project is too large, it will create problem for tracking the files. So when you have a large project, it's preferable to mention every source file. And notice after we add this function, warning is printed. It says CMake minimum required, version is not mentioned, so we have to add this line into our CMake list file to avoid this warning. And this is important to determine which minimum version of CMake that can compile the code. So in case you send this project to someone who has a version less than the one mentioned here, he has to upgrade the CMake version, and by this you avoid a lot of errors that might happen during compilation. Let's now separate the source files and the header files into two folders in more organized way. So in the project we have the include folder and the source. The include contains the header files person.h, and the source folder contains the .cpp files person.cpp and student.cpp, and still we have the main.cpp outside, and it's kind of organizing the code as you see here. So now we have source, we have include, we have main, and we have the build folder, and we have the file for the CMake. And as you can see, this listing the files inside the of include. It has the headers, and the source has the CPP. And now if we try to call the CMake command, a warning will be generated, compilation or an error is generated. This error is saying include file, no such file or directory. It's because we moved the header files into different directory, which is include. In the previously it was seeing it because it's in the same, all the header files are in the same project beside or in the same folder beside the .cpp files. So to solve this, we have to call include the directory, and include directory we added the folder name, which is include, and now we don't see the error message, so previously. C++ version flag. Suppose here we defined a std map, and we loop over this map, and this required C++, this way of iteration required C++ 17, and this is why a warning is printed that you have to use with the flag stdd. std C++17 when calling the make file, and sometimes error is printed if you compile with the wrong flags. So in order to add this flag to the CMake, we can use target compile features method. So target compile feature, we added it after the add executable, telling this executable is going to be executed to be compiled using C++17. And now here you can see the warning is gone. CMake also offer another method to generate the library instead of executable file, using the method add library. So add library, and this is the library name person, and this is the sources variable. Note this message is just for printing the source variable value. So add library is the function we use to generate library. We don't here, if we don't mention shared explicitly, it means static library is going to be generated. So when you call the make command, instead of the executable generated, now .a, which is static library, is generated, as you can see here. And if you need dynamic library or .so library, the same add library command or function, and this is the library name, and you have to add the shared keyword. And by this, when you call the make command, the library generated is person.so, which is a shared library. CMake install. So remember, the main executable and all the libraries we generated are built inside the build folder. Now, using the install function, you can install the generated executable or libraries into a specific location. For example, here, install, and it takes target. What is the target you want to install is project name. Notice here I defined the project name as a person, and CMake has internally set some variables like project name. Project name takes it from this function, because I set it to person. So project name variable now is equal to person, and now I can use this variable everywhere in the CMake file. So add library, the name of the library is the name of the project name, which is person, and also I use it here in the determine which C++ version I has to use, and when I do the installation for this library, so the target library or executable is the same as project name. The destination is where I want this library to be installed, so it's the project source directory / libs. Project source directory, it's the same directory path that has the CMake list file, and in this case it's the example _1, the full path to it, and /lib, so the target library will be installed inside example underscore one libs, as you can see here. So after calling the make command, it link and create person.so inside the build, but now I need to install it, so I called this new command, which is called make install. It will do installing inside the library, the path that we determined here. So now this path and this folder even is created called libs, and inside it has the dynamic or the library that we created using the CMake list. That's all. Thank you for watching.